I skipped the first slide. That was the headquarters of Steinbeis Innovation Transferzentrum. It's an innovation network consisting of 1,000 institutions worldwide. The problem we started dealing with was, is it possible to bring this technology we have heard the whole day into the practical use of an ENT specialist on a day-to-day practice? And in other formulation, how can we integrate 3D modeling, CFD simulations, and so on into the clinical pathway of an ENT surgeon? So, among many problems, for example, what computer facilities we need. Today we have heard we need HPC computers for CFD analysis. We have just heard about 3D modeling techniques. We tested a lot of things, and at the end we came up some months ago looking into artificial intelligence to support the 3D modeling. The reason behind this is that we have around 2,000 patient data, anonymous data, CT scans, and we can make use of this mass data. And the game-changing technology at the moment is artificial intelligence, which is based in mass data. So we have a good basis to introduce this technology. And the detailed problems here, for example, are how we can segment on the bone. For example, region of interest is the maxillary sinus. So it's, let's say, the hard material. Another question is how we can identify the tissue, even it's pathologic or not, from the maxillary sinus. You have it on the right side. These are screenshots of 3D slicer, sorry. And on the left icon, you see we are entering a picture that is part of the maxillary sinus of a CT slice. And then after some feature extractions, we can classify according to some procedures what is in this image. If we go more in depth, we looked into different solutions. It was very nice for myself. I published in '72 already a classification system for EEG data based on statistical methods. So it brought me back after 45 years. Again, now it's artificial intelligence. So the problem is we have an axial CT slice as an input, for example. We have on the bottom a manual segmentation created by an employee. This takes from some minutes to up to 24 hours. It depends on the quality of the slices and so on. And then we have in the middle the automatic segmentation by the, we are using convolutional neural networks. And if you compare these two images, then it is an air segmented image. Very important is the reduction to two gray shades, white and black here. And this automatic segmentation is done within seconds for an image. And I have told you we have 2,000 images. When we started the project, we looked about having some hours for segmentation to get mass data for analysis. It would have taken many years, or person years, to do that. Now we can segment around 500. We can reconstruct 3D models, around 500 pieces in one night. So 2,000 models is a matter of 2 days, probably 3 days maximum. I cannot really go into detail, but the workflow is you have to develop sets of data. We call training sets, validation sets, and test sets. And we need, of course, manual segmented 3D models. we have to select hyperparameters, creating the CNN structure. We're using proven technology. It's TensorFlow, developed by Google. And we have built a computer based on GPUs. Up to now it's 3 GPUs, but we have a nice supplier in China who delivered us already the hardware. We can use up to 10, 20 GPUs at the end, if necessary. A very important thing is point 3, so it is more or less the cost function. You have to optimize this network, and it's related to deep learning. So the network is able to learn itself out from data. And this is, if you're working in business, for example, simplex algorithm or something, you have functions to optimize. And I looked into these functions. I think behind there is the entropy function from Shannon. This was developed probably 50 years ago. Then we have different algorithms. I have put some, if you can download the presentation, don't know. We have some algorithm, momentum, atom optimize, and so on. Explaining this would take probably 2 days. What are we doing with that? And what's the benefit? And these are actual things we are investigating. For example, we are tested the drug delivery of parasinus, for example. So this is a pulsatory airflow with at 1650 Pascal with 44 megahertz. You see it on the right side. Then we are comparing the volume of a patient in different years, for example. What we have seen from Jochen, the CFD simulations, we were using open foam runs and less technology. Nothing is 3D printing. We did test the different printers, and at the end it ended up with a 200 euro printer. You can do this like this here already in 2 materials. So you have here the hard part, you have the tissue part. The next we are looking now for biomaterial. Then for what reason? We can use it for a treatment simulator. So in the first we thought about virtual surgery. Then when I attended several surgeries, I found out the haptic element is very important for the surgeon. So we are now working on a treatment simulator, which we can use the devices for surgeons. I'm above my time, sorry.